Hello, good morning. Today we'll be learning how to graph a rational function. So we are asked to graph the function x minus 2 divided by x squared minus 4. So the first thing you always want to do when you graph a rational function is to find the asymptotes, right? So the asymptotes are the imaginary lines that split the graph from left to right or up down. So the vertical asymptote will split the graph left to right. So given this problem, what I want to do is to first factor the denominator because it looks like it can be factored. We have x squared minus 4. So these are difference of squares. So I'm going to factor, okay? So it's going to look like this. X minus 2 divided by, if I factor x squared minus 4, that gives me x minus 2 x plus 2. At this point, I believe we have mastered our factoring. Okay, so we can see that there's a common factor of x minus 2, x minus 2. So those two can cancel out, okay, if you want. So this expression is now going to look like this. 1 over x plus 2. Okay, now what this means is that when these two factors cancel out, it is going to create something we call a whole. And I'm going to explain that in a minute. Okay. So, first of all, how do we get a vertical asymptote? The rule for getting the vertical asymptote says you take the denominator, you set it to 0, and you solve for x. So I know the denominator is x minus 2, x plus 2, right? So I have x minus 2 x plus 2 equal to 0. I'm trying to find a vertical asymptote. Let's call that VA. VA for vertical asymptote. So if I set each factor to 0 and I solve for x, I'll be getting x equals to 2 here, x equals to negative 2. Now, these two were supposed to be the vertical asymptote. However, you realize that here we said that the x minus 2 will cancel out. So because this factor, the x minus 2 cancels out, instead of this becoming a vertical asymptote, it is now going to turn into a whole. So the only vertical asymptote is going to be x equals to negative 2, which we can see is going to come from here, this in the denominator, right? So our vertical asymptote, right, so therefore the vertical asymptote is going to be x equals to negative 2. So again, this is not going to be a vertical asymptote, but rather that is going to be a whole. So there's going to be a whole. There's going to be a whole at x equals to 2. And the reason is because, as I said, those two factors cancel out. The x minus 2 cancel out, and therefore creating the whole at x equals to 2. Okay, so now the other asymptote we need to find is the horizontal asymptote. How do I find the horizontal asymptote? Let me use the red color, actually green. To find the horizontal asymptote, what we're going to do is that we are going to compare the degree of the numerator to the degree of the denominator. Okay, if they are the same, then we are going to divide the leading coefficient of the numerator by the leading coefficient of the denominator. If they are not the same, if the degrees are not the same, then we are going to make them the same by introducing a 0. Okay, so here we see that the degree of the numerator is a 1, the degree of the denominator is a 2, so they are not the same. So to make them the same, I'm going to introduce a 0 term in the numerator, so 0x squared. So by so doing, now the degrees are the same, degree 2, degree 2. So now I can divide the leading coefficient. Don't forget the leading coefficient here is a 1. The leading coefficient is the number that is multiplying the highest degree term. Right, so here I have a 1, here I'm going to have a 0. So if I divide, I'm going to get 0 over 1, which is equal to 0. So therefore, my horizontal asymptote is going to say y equal to 0. And we always use y to represent the horizontal asymptote and x to represent the vertical asymptote. And the reason is this: the horizontal asymptote is going to cut the y-axis, and therefore y equals. The vertical asymptote will cut the x-axis, and therefore x equals. Okay, so now let's go and draw the asymptotes. Now I know my horizontal asymptote is x equal to 0, so I'm going to draw that, and we are going to use dashed line to represent asymptotes. We don't do solid lines. So that is my vertical asymptote of y equal to 0, and I have the vertical asymptote of x equals to -2, right? X equals to -2 as my vertical asymptote, y equal to 0 as my horizontal asymptote. So let's just, so -2 on the x is going to be here. So I draw the vertical asymptote nicely. Again, we use broken lines or dashed line. Okay, so that is what we see here. Now, I need to find some points on the graph to help me get the shape of what the graph is going to look like. So I would normally start off by finding the y-intercept. Y-intercept. So to find the y-intercept, let me do it down here. To find the y-intercept, right? To find the y-intercept, I'll make x equal to 0, because on the y-axis x equal to 0. So we are going to plug in 0 for x so we can solve for y, right, in the equation. So I'll have y equals 1 over 0 plus 2, which is equals to 1/2. So the y-intercept is going to be 0, 1/2, right, 0, 1/2. So let's draw that. So the y-intercept is going to be here, right, it's going to be here 1/2, which is 0.5. Okay. Now, is there going to be an x-intercept? No, because of the horizontal asymptote. For this particular graph, we will not have x-intercept. So what I'm going to do is I'm going to quickly get some additional points, okay, so that I can get the shape of the graph. So let's say I plug in x equals to 1. If I plug in x equals to 1, okay, I'm going to get 1 over 1 plus 2. So that becomes 1 over 3. So if x is equals to 1, okay, then y is equals to 1 over 3, which is 0.03, 0.333, right? 0.333. So something closer here. Okay. Now, we know that if x is equals to 2, let's go back here. If x is equals to 2, we know there's going to be a hole, right, when x equals 2. So at x equals 2, there's going to be a hole. There's going to be a hole. So I indicate that hole, right? We know that at x equals to 2, there is a hole. So that's the hole right here. Now let's plug in additional x values to find additional points to graph. So let's say I plug in x equals to -1. If x equals to -1, what would be the y value? If x equals to -1, I have 1 over -1 plus 2, which becomes what? 1. So if x equals to -1, if x equals to -1, y equals to 1. So that will be that point right here. Okay, so you can plug in additional points. So for the, I think that these points are good for the right. Now for the left hand side, let's plug in some numbers. Let's assume I plug in -3, right? If x equals to -3, if I plug in -3 here, that would be 1 divided by -3 plus 2, which becomes -1. So this one becomes negative. So if x equals to -3, y equals to -1. So that is going to be here. Okay. How about if x equals to, let me pick something like -2.5. Okay, if I plug in -2.5 here, I end up with 1 over -0.5, which translates into -2. So when it's -2.5, that will be -2. So down somewhere down here. Okay, maybe let's add one more. How about I plug in -4? Right, if I plug in -4, if I plug in negative 4 here, I get 1 over negative 4 plus 2, which becomes 1 over negative what? Negative 2, right? So which becomes negative 1/2. So when it's negative 4, I have negative 1/2 somewhere here. So I think these points are enough to get the shape of the graph, right? It's not going to be accurate, but at least we will know how it's going to look like. So the graph is going to look something like this. Remember, it will not touch the vertical asymptote. Come down, right? There's a hole right there. It goes like that. Then on the left-hand side, it's going to look something like that. Goes through the points. Get closer to the asymptote, but will not touch it. So the graph looks something like this. Okay. So with that said, let's quickly see if I want to find the domain of this graph. The domain of this graph is going to be all the x values from negative infinity. It gets to negative 2. There is a break at negative 2, right, because of the asymptote. Then it goes all the way from negative 2. It gets to 2. There is a hole because the graph is not defined at negative 2. Then from 2 all the way to the right. So if I want to write a domain, it's going to look like that. Okay, so the domain, let's call that D, will be in an interval notation from negative infinity all the way to negative 2 union, because there's a break there, there's an asymptote, negative 2 all the way to 2, there's a hole at 2, union, from 2 all the way to positive infinity. All right, so that could be, or you can write it like this. In some books they will say all real numbers except x equals to negative 2 and 2, right? Those are the x values where the graph is not defined. Okay, then you can talk of the range. The range will be all the real numbers except what? When y equal to 0, because there's an asymptote right there, and whatever the value right here is at the hole, right? Very close to that. So I hope this was very helpful. Now let me ask one good question. Let's say I ask you, as x approaches negative 2 from the left, this one means from the left. So if I'm approaching negative 2 from the left hand side coming this way, what will be the f of x? In other words, the y approaching. So if I'm coming from the left approaching negative 2, the f of x is going down, so that will be negative infinity. Okay, so I hope this was helpful. So let's summarize. You first find the asymptotes, vertical, horizontal asymptote, graph the asymptotes, then plug in some x values to find out additional points to graph. All right, I'll see you in the next video. Bye bye.